Now, we are continuing with our lectures on applications of ChatGPT in the healthcare sector. We are back to our familiar website, https chat.openai.com. You just require one email ID to create an account, and you can use the free account. There is a possibility of upgrading by paying $20, but that is something which one has to decide later on. Now, as far as previous lectures were concerned, one important feedback that was received was that those lectures were useful for mainly medical education, but in actual clinical practice setup, the situation is slightly different. Now, that's true, but please attend these and the next lectures because although machine learning and artificial intelligence experts have admitted that healthcare is the most difficult domain for uh, to tame it and to use these ML and AI tools. But at the same time, a lot of developments are occurring, and this particular lecture will take some difficult kind of prompts, which are actually useful in the clinical setup, and these are tried and certified by a doctor herself. So I can show you the name of the person is yeah, Ranjini Ramamurthy, and this is her brief intro. This particular, so yeah, product management, MD, cancer research, engineer, and she has worked with giant companies like Truveta and Microsoft and Fred Hutch and like that. So there was another feedback also that these things are only in developed countries and they are far away uh, from our country. So there is no need to worry. Of course, there is no need to worry because as I am going to show that healthcare professionals are perhaps the most protected people as far as fear of job loss due to artificial intelligence or machine learning they are concerned, that is concerned. But the purpose of this tutorial is that these tools have already far exceeded what we believe normally they can achieve. So this today we are taking some difficult prompts, and many of them are heavily borrowed from this blog. So all credit to Miss Ranjani Ramamurthy. Who she will not mind. Okay, now let me start with the first prompt. Now here it is a actual clinical situation. Extract all clinically relevant diagnosis only from this blurb of text. What is that meaning blurb of text? I'm coming to that. Differentiate between PMH and current chief complaint. So this PMH and all that, they are typical doctor's terminology, and we are using already them, and we are testing whether ChatGPT can understand them as not or not. Or that means we are uh, testing ChatGPT whether it can work as an accomplished medical assistant, okay, who can help a doctor to reduce his or her workload. Okay. and we want the output information. We also want certain diagnosis. We clarify that diagnosis. Yeah, here we are clarifying that presenting just symptom is not the diagnosis. So that means that you name the actual disease, and we are asking it to give it with a how degree of confidence. So we are actually using this as a clinical decision support system. And I will tell you in some other lecture that at least 14 to 15 big clinical decision support system products are widely being used in many countries. So let us use ChatGPT as this. This is the patient's history. Now, about that blurb of text, these are the highlighted portion, that is that blurb of text. Okay, so this is how doctors usually work, that some assistant takes the history, and doctors eyes are so trained that they do not read each and every word, but their eyes automatically go to the keywords. So some was first keyword is medical history of smoking, then this is the past history when he was admitted and what procedure was done on him or her, he here. So then what is the past medical history, and this is the allergy history. So usually a doctor quickly goes through this key portion, because these are the key portion which can I mean make a hell lot of difference between one diagnosis and the another. Okay, so let us see whether ChatGPT can understand this history, whole history given in this long format. And instead of highlighting, I will put them in square brackets. So let us see what happens. Okay. Now I come back to our chat GPT. Yes. Here that same history is put, only the highlighted portion instead I have written that blurb of text is placed inside this kind of square brackets. Okay. And rest of the things are identical. Now let us see what answer is given. And you can see that it gives answers in very, very uh, uh, expected manner and scientific manner, that this is the diagnosis. Okay, and again it is using some scientific terms, CAD, HTN. Now, you know about ChatGPT that it is a conversational AI. So suppose a layman is using this, then he can ask that please expand all these terms and then name these terms by comma separated, CAD, HTN and all that. Okay, right. Now, here it is giving the probability of each diagnosis, that this has a high probability. This diagnosis have also high probability, while the other diagnosis have less probability. Okay, or rather medium probability. Okay. Also, it tells about the condition, that this is a condition, this particular poor liver function is active, but it is resolved, because that is from past history of patient. So these things the patient had, but these things are already resolved. Okay. While these things are already present in the patient, this is a middle column, and they are chronically present, and this is active. This is also active. Okay, fine. Let us try to query this chat GPT about its answer. Renal functions. Okay, what did it answer about renal functions? If you see, then acute renal failure. Uh, has it given that output acute renal failure? Uh, Let me check in that block, because every time it gives different output based on probability. So acute renal failure was given as an output or not. Mm, I think it was more or less this output only. No, it was not given. So yeah, here it is, acute renal failure. But in our case, acute renal failure is, I think, not there, perhaps. So it has already learned that. That is an important thing, because in this previous, when this Miss Ranjani, etc., researchers were testing it, they tested it further. That they challenged the system, that how can you give acute renal failure? Yes, the chronic PMH of patient includes this and this. No, that's not explanation. Yeah, the here the patient's renal function returned to normal over several days. However, so does this change the probability of status of diagnosis of acute renal failure? Here it had given acute renal failure as one diagnosis and given the medium probability, but the doctor is challenging. So doctor remains in control, and these tools are used. Okay, they are just used for making the work easy. So then doctor challenges and it admits that where is that acute renal failure? Yes, here it admits that the statement patient's renal function returned to normal over several days indicates that acute renal failure has resolved. So the status of the diagnosis should be uh, changed from active to active resolve, and the probability of the status being resolved is now high. So the probability should be changed and the status also should be changed. Okay. So this is one good example of how you can, and in our case, acute renal failure is, I think, not seen. Yes. So that is the beauty of this kind of models, that as somebody uses it more and more, actually it's the same data, same prompt was used by those researchers. So, and then they challenged the model. So the model learned from that. And next time when we asked, then it did not give that acute renal failure anywhere. At least I don't see it. It is not there. Okay. So this is how the model will keep on improving itself. And that's the great thing about this. Just like a doctor as goes on practicing over years, goes on improving, this is also like that.